When Einstein introduced his general theory of relativity in 1915, it revolutionized physics. But it also created a problem. If spacetime could bend and warp, then under the influence of gravity, the entire universe should be either expanding or contracting. Einstein, however, believed the cosmos was eternal and unchanging. To fix his equations, he introduced an extra factor in 1917, the cosmological constant, a mathematical trick to keep the universe static. Ironically, this correction would later be called Einstein's greatest blunder, because just a decade later, evidence began to show that the universe was not static at all, but expanding. In 1927, a Belgian physicist and Catholic priest named Georges Lemaître published a revolutionary paper, A Homogeneous Universe of Constant Mass and Growing Radius Accounting for the Radial Velocity of Extragalactic Nebulae. In it, he proposed that the universe was expanding, and that distant galaxies were rushing away from us. He went even further. In 1931, Lemaître suggested that if the universe is expanding today, then in the distant past it must have been smaller, compressed into a single point which he called the primeval atom. This was the seed of what we now call the Big Bang theory. At first, many scientists resisted his idea. Even Einstein himself dismissed Lemaître's work, reportedly saying, "Your calculations are correct, but your physics is abominable." Still, Lemaître held his ground. Time would eventually prove him right. Around the same time, an American astronomer named Edwin Hubble was working with the 100-inch Hooker telescope at Mount Wilson Observatory in California. In 1924, he made a discovery that shook astronomy. The nebulae seen in telescopes were not clouds within our Milky Way, but entire galaxies of their own millions of light-years away. By 1929, Hubble had gone further. Measuring the light from these galaxies, he found they were all redshifted, meaning they were moving away from us. And the farther a galaxy was, the faster it seemed to be receding. This relationship became known as Hubble's law. The implication was staggering. The universe itself was expanding. Suddenly, Lemaître's theory looked much more plausible. Einstein, after visiting Hubble in 1931, is said to have admitted, "I now see that the universe is expanding." The cosmological constant was abandoned, at least for a time. Even with Hubble's discovery, not all scientists were convinced by the idea of a cosmic beginning. In the 1940s and 50s, an alternative gained popularity, the steady-state theory proposed by Fred Hoyle, Hermann Bondi, and Thomas Gold in 1948. According to this model, the universe was indeed expanding, but it had no beginning and no end. Instead, new matter was continuously created to fill the gaps as galaxies moved apart, keeping the universe eternal and unchanging in appearance. Hoyle even mocked Lemaître's idea during a BBC broadcast in 1949, calling it the Big Bang, a nickname that stuck, though he meant it derisively. For a while, the scientific community was divided. Was the universe eternal, or did it truly have a beginning? The debate raged on until the 1960s. Then came the discovery that settled it. In 1965, Arno Penzias and Robert Wilson, two radio astronomers working at Bell Labs in New Jersey, were trying to eliminate static noise from their giant horn antenna. No matter what they did, cleaning pigeon droppings, adjusting instruments, the noise persisted. What they had stumbled upon was nothing less than the faint afterglow of the Big Bang itself, the cosmic microwave background radiation, CMBR. This was the cooled remnant of the intense heat that once filled the universe, stretched by billions of years of expansion. Their discovery earned them the 1978 Nobel Prize in Physics, and effectively killed the steady-state theory. The Big Bang was no longer just a hypothesis. It had become the accepted foundation of modern cosmology.